Hey there, everybody. Welcome back. Good to see you all again. We are working on 3.2, which is scientific notation. So the idea is write really large and really small, or really small numbers with less zeros. Because if we have like yeah, let's do some more. That's annoying. The calculator won't even show that many. So the way we end up doing is we condense it down to a form where we have a times 10 to the nth power, where a is greater than 1 or equal to 1, but less than 10. So it needs to be a single digit. The number needs to be a single digit. We might have some decimals with it. But the number in front of the decimal point will be less than 10. So the idea is count the number of times you would move the decimal place. I would move it 3, 6, 9, 12, 15, 18. If I have to move it to the left, this can be rewritten with the decimal after the 5, so it's between 1 and 10. And I moved it 18 times, so this is times 10 to the 18th power. If I were going to move a really, really small number, shows up in science. We count how many times we move it to the right. I think it's easier to track in increments of 3. And one more, 13, 3.92 times 10 to, now we do negative 13. So, rules. Step A, move your decimal point. So that the overall number is between 1 and 10. We don't want to include 10, so and while you're doing that, count your steps. How many times did you move your decimal point? B. Write your number times multiplied by 10 to the nth power, where n is the number of steps. And if you moved it left, n is greater than 0, so it's a positive 1. And if you move the decimal point right, n will be less than 0, so negative. Okay. So what can we do with that stuff? Doing operations on these things. If I have like a times 10 to the n and b times 10 to the m, this is really a times b times 10 to the n times 10 to the m. You'll combine them. And if this new number is, if the new number is greater than 10, or equal to 10, we got to move the decimal more. Same thing happens if you have a times 10 to the n over b times 10 to the m. You're going to end up with a over b times 10 to the n minus m. Let's take a look at some examples real quick. Okay. .27 times 10 to the fourth multiplied by 4.13 times 10 to the ninth. This ends up being 3.27 times 4.13 times 10 to the 4 plus 9. Interestingly enough, we still use the x for scientific notation. Even though every other multiplication we use a period, a dot, not a period. What is 3.27 times 4.19 or 3? So I end up getting 13.5051 times 10 to the 13th. But now my number is bigger than 10, so I need to move the decimal left, which means I'm going to add one more here. And I'll have 1.35051 times 10 to the 14th power. Oftentimes you still have a lot of extra numbers, but like on big numbers, these last numbers don't matter so much. You would round this to 1.35 times 10 to the 14th. Why do I say it doesn't matter? Let's say you had, 3,981,540,310. If you've got $3 billion, do you really care about this? No. 500,000 is chump change to somebody with $3 billion. That's equivalently if I had $3.98 or $398.15 and asking you, is the nickel important? Not really. You would round and say I have $398, or maybe you might even round to 400. So like we end up doing a lot of rounding. You would round maybe to 3.98 and turn all of those into zeros. And you might even round to 4. But having a couple decimal places isn't too bad. That is way better than 3.98154,031 times 10 to the 9th. That's not helpful. We actually didn't make it any shorter. We made it longer. But this shortens it down. All right, let's look at another one. We've got 0.0000789 squared. If I move the decimal, I got to move it right 2, 3, 4, 5. This is 7.89 times 10 to the negative 5 squared. This ends up times 10 to the negative 10. If I square 7.89, I get 62.2521. Times 10 to the negative 10. I'm going to move the number left one, which means I got to add 1 to the exponent. And we get 6.22521 times 10 to the negative 9. And I would probably round to 3 digits. So 6.23 times 10 to the negative 9. Because I only had 3 digits here that mattered. So I should only really have 3 digits in the answer that matter. All right, you guys try. 39,600 times 0.00264 divided by 0.0000132 times 32 million. Pause the video, give it a try, then come back and see what I do. This is 3.96 times 10 to the 4th power. This is 2.64 times 10 to the 3rd power. Negative 3 power, sorry. This is 1, 2, 3, 4, 5, 1.32 times 10 to the negative 5. And I got 3.2 times, not negative 5. Yeah, negative 5 on that one. And this is times 10 to the 7th. So I've got this times that divided by 1.32 divided by 3.2. I'm going to need to do that. Then I have times 10 to the 4th power minus 3. I'm using rules of exponents. Then I'm going to subtract the exponents on the bottom, minus negative 5 and minus 7. So what does that end up being? 4 minus 3 is 1. 1 plus 5 is 6. 6 minus 7 is negative 1. So that part turns into that. Now we'll do division or multiplication division, work out all this. 3.96 times 2.64 divided by 1.32 divided by 3.2 equals 2.475. And I'm going to make sure I got the right number there by doing the multiplication again. Yep. There you go. That's scientific notation. Quick section. Peace.